Hello friends, welcome to Learner's Planet. Friends, once again I'm here with the next session of permutation and combination. In the previous session we discussed so many problems and concepts. Precisely we discussed application of combination, right? We discussed like the problems based on number of diagonals formed, number of lines formed, number of triangles, quadrilaterals formed, right? Problems based on handshakes and gifting, right? So in this session, we'll have a quick recap of the problems that we discussed in the previous session. Then we'll go for the multiple choice questions, right? So precisely we will be doing the applications of permutation and combination in multiple choice questions, right? Because in examination, in entrance examination, multiple choice questions are asked. Okay, so let's begin the session. Now friends, let's have a quick recap of the concepts or the problems that we discussed in the previous session. Here, a polygon has 44 diagonals, find the number of sides. In the previous session, we discussed the similar concept, and it takes 2 points to make a line, right? But each line is not a diagonal. If we match two adjacent points, we won't be getting diagonal, right? And we derive the formula for the same also, that is NC2 minus N. Right, so the number of diagonals for any polygon having n sides is nc2 minus n. Now nc2 minus n is 44, that is given in this case. Now see, if there are options, you just put the value of n from the options and match it to right hand side. But here I'm not having options, so I just formally solving it. What nc2 is, just reduce n to 2 steps, that is n minus 1 by 2 minus n is 44. So let's solve this quadratic equation. It's n square minus n. It's n square minus n minus 2n, that means precisely it's minus 3n is equal to 88. So it's minus 88 is equal to 0. So it's n minus 11, n plus 8 is equal to 0, right? So it's n is equal to 11. Right, so the polygon is having 11 sides, right? So if you are having options available with you, just put the value of n from the options, that is 11c2. So 11c2 is what? 11 into 10 by 2, that is 55. 55 minus 11, 44, right? So 11 is the correct answer. So this is how we calculated number of diagonals in the previous session, and here I have shown you once again. Now similarly, take up the next problem. Just wait for a moment. Now, there are 10 points in a plane, no 3 of which are in the same straight line except 4 points are collinear, right? So we have 10 points, and out of these 10 points, 4 points are collinear, right? Just it's an important information. Then we have to find the number of straight lines obtained from the pairs of points. First of all, let's calculate that. So it takes the 2 points to make one line, right? So what we will be getting, total number of combinations taking 2 points together from 10 points will be 10c2, right? So in all we will be getting these many lines, but there are 4 points which are collinear, right? So we have to eliminate the combinations formed by these 4 points, that is 4c2. Further, we will be getting exactly one line if we match all the 4 points, so I have to add 1. So this is the total number of lines which we are going to obtain from these 10 points, right? Out of which 4 points are collinear. I repeat it once again. See, lines, we can get the line, we can form the line by combination of 2 points. So in all, from the 10 points, we will be getting 10 C2 combinations, but we need to deduct the combinations formed by these 4 points which are collinear. So we deducted all the combinations, but we will be getting one and exactly one line if I have to match these 4 points, right? So I added that, because while deducting this 4c2, I eliminated all the combinations, right? The combination of this and this also, right? But we will be getting one line if I match this with this, right? So plus 1. So in all, these are the number of lines, right? So 10c2 is what? 10 into 9. 10 into 9 by 2, that is 45. Minus 4c2 is what? 4 into 3, that is 12 by 2, 6 plus 1. right? So it's 45 plus 146 minus 6. 40 lines I will be getting, right? So we got the answer for this problem. Next is number of triangles can be formed with the vertices at these points. Further, it takes 3 points to draw one triangle. So in all, these are the total number of combinations while we join the 3 points. But once again, 4 points are collinear, so we won't be getting any triangle if we match up 3 points from these 4 points. Suppose we have these 4 points. So if we match these 3 points or these 3 points or these 3 points, we won't be getting triangles. So we need to deduct all the combination of 3 points from these 4 points from this, right? So it's 10C3 minus 4C3, that is the total number of triangles. So what 10C3 is? It's 10 into 9 into 8 by 3 factorial, reduce it up to 3 steps, then divide by factorial of denominator. That is 3. I'm sorry, it's not denominator, it's this number. So this is R like, so this is 6 and 4C3 is 4, right? So it's 3, 2, so 10 3s are 30, 2s are 60, 60 minus 4 is 56. I'm sorry, I did wrong calculation over here. It's 3, I just do it once again. It's 10C3, that is 10 into 9 into 8 by 6 minus 4, right? So it's 3, it's 4, and this is 3, right? So 10 3s are 30, 30 4s are 120, 120 minus 4 is 116, right? I just made calculation mistake over here, so I'm sorry for that. Finally your answer is 116, right? Be careful on making calculations, right? Now friends, let's take this question. In a 12-story building, 3 persons enter a lift cabin. It is known that they will leave the lift at a different story. In how many ways can they do so if the lift doesn't stop at the second floor, second story, right? That means 3 persons are there, 12-story building is there, from one maybe from any of the floor they have entered the lift cabin, right? So suppose first person, if we talk about, maybe the 3 persons are A, B, C, right? Now the lift doesn't stop at the second floor, and the person are entering the lift from any one of the floor, right? So they will not, none of them will get out of the lift from the same floor from which he is entering, right? So we eliminated 2 options, that is the second floor and the same floor and the floor from which they are entering the lift, right? So A has 10 choices to get out from the lift, right? Or to leave the lift. Now B has, since all of them have to leave the lift at the different floor, so A has 10 choices, that means B has 9 choices and C has 8 choices, right? So it's 720. Or else from these 10 floors we have to select any 3 floors on which A, B and C will leave the lift, right? Now we have selected the 3 floors. Now the order in which A, B and C will leave the lift will be 3 factorial, right? 3 persons are there, so 3 factorial ways are there to arrange them. So 10C3 into 3 factorial, that is 10 into 9 into 8 by 3 factorial into 3 factorial, so it is 720, right? So you can go either way. This is the combination method and this is just the arrangement, right? So I think you are clear. It's 720. Now friends, let's see this problem. The number of ways in which 6 different books can be distributed among 5 students. Here friends, there is no condition given that one particular book is given to one particular student, or maybe all of the students should be getting books. That means no conditions are there, right? So there is how many ways will be there? Suppose there are 6 books A, B, C, D, E and F, right? And the 5 students are there. Now suppose we take up the first book. Now we have how many options to distribute this this first book? That is 5 options, right? We can give the book to any of the 5 students, right? For the second book, we still have 5 choices. For the third book, we have 5 choices. For the fourth book, we have 5 choices, for the fifth book and for the sixth book. So for all the books, individual books, or for each book we have 5 choices. So in all there are 5 raised to 6 ways to do this, right? See, good number of students get confused, like it will be 5 raised to 6 or 6 raised to 5, right? Because various fundas are available on various books. Just give the smaller power to the bigger number or bigger power to the smaller number, right? But don't go with these methods, like these are just confusing methods, right? You just have to go conceptually. See, what are you distributing? That is the books, right? Now for the first book you have 5 choices, for the second book you have 5 choices. Write it like this, you'll instantly get the answer, right? To get this answer, what will you speak? Just listen to me, what I'm speaking over here, whether this is valid or not, right? I have 5 students, maybe student 1, student 2, student 3, student 4, student 5, right? Now first student have 6 choices, right? 6 books are there, so first student have 6 choices, second student have 6 choices. Is it valid? No. Student doesn't have to choose the book has to be given to the student. So this is not valid. So we won't be getting this answer, right? So be very clear about the difference between these two, right? What you are going to do, see, there is number of students are there and you need to distribute the books, right? So for each and every book you have choices. For student, you don't have choice of books, but for books, you have choice of students, right? So you have to go this way. And what I'm doing over here, I'm just applying common sense, nothing else, right? No big mathematics or no big permutation combination fundas are involved over here, right? Be very clear. Now, similarly, there are 10 true false questions. The number of ways in which they can be answered is, right? Now, we have 10 questions. For every question, we have 2 choices. It's true or false, right? Suppose I pick up question number 1. I have 2 choices whether I will mark true or false. Then I pick up second question. I have further 2 choices, true or false. Then for the third one, for the fourth one, for the fifth one, till 10th one, right? So 2 raised to 10, right? The same funda I'm applying over here that I have applied in the previous question, right? Choice are where are choices that you need to think, right? You picked up the question, then you have 2 choices. So for the question you have choice, for the choice you don't have questions, right? So for the first question you have 2 choices that you will mark either true or false. For the second question similarly you have 2 choices that you'll mark either true or false, right? So till 10 questions you have 2 choices for each question. That means it's 2 raised to 10. Okay, it's very important. Now friends, let's see this question. In an examination, a candidate is required to pass 4 different subjects, then the number of ways in which he can fail is. Friends, various methods are there to approach this problem, right? I just take 1 or 2 methods. Suppose, see, there are 4 subjects, right? Maybe A, B, C and D, right? The candidate has to pass 4 subjects, and what are the number of ways in which he can fail? That means he has to fail in all the 4 subjects, or all the on the 3 subjects or 2 subject or 1 subject, right? He cannot pass all the 4 subjects, right? So the first method is, he is pass in for subject A, he has 2 choices, either he is pass or fail. For the subject B, he has 2 choices, pass or fail. For the C, pass or fail. For D, pass or fail, right? So there are 16 ways in which the total number of ways will be 16. But for every case, we have taken that pass or fail, pass or fail, pass or fail, and pass or fail, right? But there will be a single case when all the 4 are pass. So if all the 4 are pass, we cannot calculate the number of ways in which he can fail, right? So these are the total number of ways in which he can fail or pass, and we need to deduct that single case when he is pass in all the 4 subject, right? Because we are choosing pass, fail, pass, fail, pass, fail, pass, fail, right? So a single case will be there when he will be pass in all the 4 subjects. So we deducted that and we got the answer as 15, right? Alternatively, what you can do, see, he has to fail at least in one subject, right? So let's calculate that. Suppose he is like fail in 3 subjects. So out of 4 subjects, he is fail in 3 subjects. So which 3? That will be calculated, that the combination we will be getting by 4C3, right? Now suppose or he is fail in 2 subjects. So the number of combinations is 4C2. Then suppose he is failed in 1 subject. So the combination is 4C1. That means the subject is either A or B or C or D. 4 combinations will be there. Or he is not at all fail. But we have to find out the number of ways in which he is failed. So we want to calculate that, right? So precisely this is the total calculation that we have to make, right? So 4C3 is what? 4C1. 4C1 is 4 plus this 4. Then 4C2 is what? 4 into 3, that is 12 by 2, 6, right? So that is 6 plus 4, 10 plus 4, 14. And one way is that he is fail in all the 4 subjects. So it's 4C4, right? So plus 1, that is 15, right? So he is fail in all the 4 subjects, or he is fail in 1 subject, or he is fail in 2 subjects, or he is fail in 3 subjects, right? So these are the cases that we taken over here. So 15 is the answer. So 15 is the answer in this case and in this case. You can go for any method. It depends upon you in which you are comfortable, right? Now friends, let's try this question. A fair dice is rolled n times. The number of all the possible outcomes is. See friends, why do we call it as a fair dice? What does this term mean? That is, this dice is totally unbiased. It doesn't follow any pattern for its outcomes, right? So this is what a fair dice is, right? Now it is rolled for n times. Now on a dice, how many numbers are there? That is from 1 to 6, right? 1, 2, 3, 4, 5, 6. And the numbers are in the form of dots, like 1, then 2, then 3, then 4, then 5, and then 6, right? Now when you roll a dice, you will or you may get any one of the number, right? So suppose you are rolling dice for the first time, so you have 6 choices, right? Number 1 or 2 or 3 or 4 or 5 or 6 may appear in the form of dots, right? So if you are rolling the dice for the first time, you have 6 choices, right? Now further, you are rolling the right dice once again. So further you have 6 choices. Then further 6 choices, right? So any number of times you are rolling the dice, every time there are 6 choices. So you are rolling the dice for n times. That means 6 into 6 into 6 till n. That means 6 raised to n, right? So the number of all the possible outcomes is 6 raised to n. Okay? I hope you are clear. Now, there are 4 letter boxes in a post office. In how many ways can a man post 8 distinct letters? Further, we have to apply common sense over here. No mathematic sense or deep knowledge of permutation combination is required over here. See, 4 letter boxes are there: A, B, C, and D. Now you pick up the first letter. So you can drop the letter in any of the boxes. So for the first letter, you have 4 choices. Similarly, for the second letter, you have 4 choices. For the third, till 8th letter, you have 4 choices, right? Because there is a restriction on which, like on letter or post office. Post box. See, a post box can accommodate more than one letters, but a single letter cannot go into more than one box, right? So we have restriction on letters, right? So if we pick up a letter, we have 4 choices, like in which we can put, right? We can put the letter either in A or B or C or D, right? So for each letter we have 4 choices. So for 8 letters we have 4 into 4 into 4 till 8 times. So 4 raised to 8 ways or choices we have to post 8 letters in 4 letter boxes, right? So it's 4 raised to 8, right? Do not get confused between these two. Good number of students get confused between the two answers. They just take the vice versa, that is, because in various textbooks or various books or in various places it has been explained that just put smaller power to the bigger number or bigger power to the smaller number, like various fundas are used. So I'm not using any funda over here, I'm just using common sense, common mathematical sense over here, right? So for the first letter you have 4 choices, for the second letter you have 4 choices, so for the 8th letter you have 4 raised to 8 choices, right? So do not get confused between these two. Now what P84 is, it actually 8P4, that is, first of all you are selecting 4 letters out of this 8 letters, then you are arranging them, right? Now this is not at all valid. See, we don't have to discuss about why the option is wrong, but since I'm elaborating it, how 8 what is 8p4, so 8p4 is what 8c4 into 4 factorial. Now why it is wrong? Because you are selecting 4 letters out of 8 letters. Why we have to select? We don't have to select because we have to post all the 8 letters, right? So this is obviously wrong. So this is what the correct method and correct choice. So I hope you are clear. Now friends, let's do this question. The number of 3-digit numbers having at least one digit is 5, right? That means one digit can be 5, two digit can be 5, and all the 3 digits can be 5. So I take a reverse approach. What I do, I take all the 3-digit numbers, and from that I would deduct the numbers in which there is no 5 at all. So in the remaining numbers there would be at least one 5, because the calculation of 1 5s, 2 5s, and all the 3 5s will be a bit difficult or bit lengthier, right? So what I do, I take a reverse approach. So how do I do that? So total number of 3-digit numbers will be, there are 3 places. For the first place we have 9 choices, for the second place we have 10, and for the third place we have 10. So in all, we have already discussed this sort of questions. So in all there are 3 digit number, like 900 3-digit numbers are there, right? Now I take, there is no 5 at all. So how many numbers are there? No 5s, right? So for the first place I have in all 10 choices, but 0 and 5 cannot come, so I have 8 choices. For the second place I have 10 choices, but 5 cannot come, so I have 9 choices. For the third place I have 10 choices, but 5 cannot come, so I have 9 choices. So it's 9 into 9 into 8, that is 81 into 8. So it's 648, right? So in all 900 numbers are there, in which 648 numbers have no 5s at all, no 5s at all. That means in the remaining numbers there will be at least one 5, right? So there may be 1 5 or 2 5, all the 3 5s are there, but at least 1 5 will be there, because we eliminated all the numbers in which there was no 5, right? So 900 minus 648, that is 252. Okay, so 252 numbers are there in which at least one 5 will be there. I hope you are clear. In this question, number of ways in which 6 persons can be seated around a table so that two particular persons are never seated together is equal to, I assume these 2 persons to be, suppose, AB, right? Apart from AB there are 4 more persons, C, D, E, F, right? Now further I would take a reverse approach over here. What I would do, I would find the total number of arrangements, and from that I will deduct the arrangement when A and B are together, right? So if 6 persons are sitting around a table, that means it is a circular arrangement, and in the circular arrangement the total number of ways arranging n people is n minus 1 factorial, right? So in all, the total number of arrangements will be is 5 factorial, that is n minus 1 factorial, right? Now next step, I just take these two people together. So I have 1, 2, 3, 4, 5 persons and 5 persons to sit at 5 places. So the total number of arrangements, further they are sitting around a circle. So the total number of arrangement will be 4 factorial into this 2 person can be interchanged also, that is AB and BA also. So to arrange these two people, I have to multiply it by 2, right? So 4 factorial into 2 are the ways when both of them are always together, right? Always together, right? So this is 4 factorial into 2, or I can say 48. This is what 120. So these are the total number of arrangements, and these are the arrangements when they are always together. So in the remaining cases, they will never be together, right? So this is what 72 ways are there when they are never together. Okay, I hope you are clear. Now, the number of different ways in which a man can invite one or more of his 6 friends to a dinner, right? That means he can invite 1 person or 2 person or 3 persons or 4 or 5 or all the 6 persons, right? So suppose the 6 persons are A, B, C, D, E and F, right? Now how do we approach this problem, right? See, he has various ways, right? First of all, we take the case when he is inviting just one person, because at least he has to invite one person, right? So out of 6, he has to select 1. So it's 6C1, right? That means he is inviting just one person. Or he is inviting 2 persons. That means out of 6, he has to invite 2 persons. So he has to take the combinations of 2 persons. So in all, 6C2 combinations will be there from this 6 people of 2 people, right? Or he is inviting 3 people, or he is inviting 4 people, or he is inviting 5 people, or he is inviting all the people, right? So these are the total number of cases that we have to calculate. So 6C1 will be 6, 6C2 is 6 5s are 30, 30 by 2 is 15. Then 6C3 is 6 into 5 into 4 by 3 factorial, so it's 20. Then 6C4 and 6C2, both of them are same. So if it is 15, it will also be 15. Then 6C5 and 6C1 same, and 6C6 is 1, right? So in all, this is the total calculation. So 15 and 15, 30, 30 and 20, 50, 50 and 6, 56, 62 and 1, 63. So total there are 63 ways in which he can invite one or more of his friends. One friend or 2 friends or 3 friends or 4 friends or 5 friends or 6 friends. So these are the combinations, right? He can select 2 friends out of 6 friends in 6C2 ways, right? So I hope you are clear. Now you must be getting the clear difference between permutation and combination, since he is inviting the friends. So here the order doesn't matter. That means in which order the friends are coming, whether A is coming first and then B is coming, or whether B is coming first then A is coming, right? Both of them are coming, so order doesn't matter. So here in this case we are just using selection, right? We are just making the combinations, right? Let's try this question. The number of ways in which a student can choose 5 courses out of 8 courses when 2 courses are compulsory. Now if the 2 courses are compulsory, so he has to now choose only 3 courses and from the remaining 5 courses, because from the remaining 6 courses, right? So 8 courses are there, 2 are compulsory, so he has to choose. There is no choice at all. So from the remaining 6 courses, he has to choose 3 more courses to make 5 courses. So 6C3. So that is 6 into 5 into 4 by 6. So it's 20. And what 6C3 is? This is 6C3, right? This is 6P3, this is 6C3. So it's 20. Okay. Now friends, let's see this question. The question is from previous year papers of CAT. So let's do it. The sides AB, BC and CA of a triangle ABC have 3, 4, 5 interior points respectively on them. So the number of triangles that can be constructed using these interior points as vertices. So first of all, I just draw this triangle. Wait a moment. So I have this triangle ABC. Right? On one side we have 3 points. On one side we have 4 points. Right? And then on the other side we have 5 points. Now in all we have like 12 points, right? And it takes 3 points to make a triangle, right? So how many combinations will we get from this 12 points? That is 12C3. That means we have to take three vertices to make one triangle. So in all we'll be getting 12C3 combinations, right? Now we have already discussed that from the collinear points we do not get triangles. So we need to eliminate the combinations of three vertices when the points are on a straight line, right? So these 3 points are on a line. So we need to deduct the combinations obtained by these 3 points, right? So it's minus 3C3. Here 4 points are collinear, so we need to deduct all the combinations from this. So it's 4C3. Now here there are 5 points on this line, so we need to deduct the combinations obtained by this 5 points. So it's 5C3, right? So it's 12C3, that is 12 into 11 into 10 by 6. 3C3 is 1, 4C3 is 4, and 5C3 is 5C2. So it's 5 fours are 20 by 2, 10, right? So it's 220 minus 15, right? So it is 205 triangles will be formed, right? I hope you are clear, and the similar problem we have discussed in our previous session as well. So I hope you won't be getting any difficulty over here to understand that we will not be getting triangles by combining the points which are on a straight line, right? So we did good number of problems in this session. Our friends will be taking more problems, more challenging problems, in fact, in the next session. Do revise this session and the previous sessions as well, because now the level of difficulty of the problems will be increasing. Okay, and you need to be conceptually clear, otherwise the sessions will be really like a pain for you, right? And why I'm telling you so, because I don't want you to lose the confidence in permutation and combination, because good number of students are confused in this topic, right? And why I'm putting so much effort and I'm solving so many problems, so you can get good amount of confidence on this topic, because it's really an interesting topic and easy to understand, right? So if you put efforts, it will be really easy task for you. If you do not want to put effort, then you just leave this topic, because if you leave this topic, then simultaneously you have to leave the topic probability also. And if we combine both the topics, so at least 2 to 3 problems from these two topics, maybe more than that, are coming in various entrance examinations, right? So I don't think there is any scope, but if you feel like, then you can drop them. And but if you wish to learn, so do revise the sessions, okay, and practice a lot. Okay, see you in the next session once again.